So when you do decide to go forward with solar testing, there's a few different parameters you're going to have to consider. You're going to have to think about your irradiance or the actual intensity of your solar load, your temperature, relative humidity, the duration of the test itself, and then part orientation too. So this can refer to the angle at which your part is fixtured, because that's going to affect which face of your part is going to receive the direct radiation versus which parts receive the indirect radiation. And then whether or not your parts need to be shielded behind glass or maybe even put into a solar box. And when you're choosing these parameters, there's a few different factors that could influence these. One of which being your geographic location. So where are the parts actually going to be used? What latitude are they going to be used at? Are they going to be used in a humid climate, or are they going to be used in an arid climate? Things like that. And then also your time of day that the parts are going to be used. So if they're going to be used mostly around noon, they're going to receive noonday sun exposure, which is going to be primarily vertical, and it's going to be relative high intensity. Or if they're going to be used towards dawn or dusk, they're going to receive horizon sun. So that's going to be a lower intensity. And of course, it's going to be coming in at a different angle as well. So one of the most difficult things oftentimes to decide on is your irradiance. So one easy way to choose this is by using an irradiance map. These can be found online. And you can see this is just color-coded based on light intensity. And as you can see here, the closer you get to the equator, the higher that irradiance level is. So I just want to now go through an example of designing an actual test and walking through the steps and choosing all of these parameters. So in this case, we're going to assume that we're testing an automotive interior component. So the first thing that we're going to want to look at is irradiance. Usually when you're designing a test, you're always going to want to base it on the worst case scenario. So if we're looking at irradiance, 1,050 watts per meter squared is noonday sun at the equator. So that's going to be your worst case scenario. So that's what we're going to go ahead and choose for this test. And then for temperature, if you've got an automotive interior component, it's going to be used in multiple climates where you're going to see a lot of temperature extremes. So we're going to choose a pretty wide temperature range of negative 30 degrees Celsius all the way up to 45 degrees Celsius. The next thing you want to going to want to look at is relative humidity. So again, it's an automotive component. It's going to be used in different climates. So what we can do in this case is split up the test between dry days and humid days. Dry days being at 30% relative humidity and your humid days being at 70%. This way we kind of cover all of our bases. And then duration, this can be another tricky one to define because unfortunately there's no universal acceleration factor for solar testing. So typically what you have to do is take some field data and use that to determine an appropriate duration by correlating the effects you see in your field data versus what you see during testing. So for this case, we're going to go ahead and say that we're going to test for 18 days, which for automotive components is actually quite standard to simulate 10 years of in-field usage. And then for part orientation, we're going to want to fixture these parts in car position. And because they are automotive interior components, we're going to use the solar box as well.